Today we're going to be talking about decay series and what different types there are and what chains exist of decay series.
So there are three types of decay: alpha decay, beta decay, and gamma radiation. First one I'm going to talk about is alpha decay. Alpha decay is a radioactive decay, and it has atomic nucleus emit a alpha particle, and an alpha particle consists of helium nuclei, which has 2 protons and 2 neutrons, and has a double positive charge. Alpha decay happens in the heaviest nuclide. It was first investigated by Ernest Rutherford, and here's the equation. So basically you can see the atomic number reduced by 4 and the mass number reduced by 2, and it emits a helium nuclide. Here's an example for alpha decay.
So beta decay, the next example, is it consists of beta particles, which are high-speed electrons emitted by an unstable nucleus. They have very little mass compared to a nucleus, because they're electrons. And it's equivalent to a conversion of a neutron to a proton, which you can see in the bottom equation right here. Beta decay's electron comes into only being when a nucleus undergoes a nuclear reaction. And the speed of the beta particle is sufficiently high that it does not end up in the orbital of the decaying atom. So in the top equation, you can see that in a nuclear reaction, the atomic number goes up while emitting a beta particle or just an electron. And next up is gamma.
Alright, now we're talking about gamma decay. So what it is, it's high energy electromagnetic waves, which is electric protons, emitted from a nucleus as it changes from an excited state to a ground state. Gamma rays actually have no mass or electrical charge, as you can see here. There's no notation, and also does not change the atomic number nor the mass number of a nucleus as represented as 00 theta. You can see here the iodine, there's no change either. Gamma rays are extremely penetrating and are actually dangerous, as they easily pass through the human body. Gamma radiation can be stopped, although not completely, by several meters of concrete or several centimeters of lead, and also occurs immediately following alpha or beta decay when the nucleus is left in an excited state. Usually when either the alpha or beta particles are excited from an excited electron, the new nucleus formed may not have too much energy to be stable, and this excess energy is then emitted as gamma radiation. Alright, so now we're going to talk about the main decay chains. So we've got the thorium series, uranium series, and actinium series.
I'm going to talk about thorium series. Thorium series is also called a neutral and classical series, are headed by neutrally occurring species of unstable nuclei that have half-lives comparable to the age of the elements. The series began with thorium-232, including actinium, bismuth, lead, polonium, radium, radon, and thallium, and end with lead-208. Basically, you can see from the chart that it has both alpha decay and beta decay. It also releases energy during decay.
And now we've got the actinium series, which begins with the isotope uranium-235 and leads with 14 different elements, including actinium, and ends with lead-207. It is also a mix of alpha and beta decay, and the total energy released is about 46.4 mega electron volts, which is actually not a lot.
Uranium series it's probably the one that's most commonly heard. It consists of uranium, actinium, bismuth, lead, polonium, practinium, radium, radon, thallium, and thorium. And like the other series, it consists of alpha and beta decay to continue the chain. And the reason why you might have heard of this is because this is used to date objects for archaeology by using each of the individual elements' half-life as a reference. Thank you so much for watching.